Okay, so now last week we talked about integration by substitution, right? So this is the one. Okay, now how do we actually use this technique, integration by substitution, to solve the problem? Okay, first, now we are going to, when we have something like this, okay, we are going to take the u. This is the u. Okay. So this is the u. This one. All right, we're going to take the u has x squared plus 9. And after that, we are going to differentiate this one. Okay, so when we differentiate, okay, we have du dx. So we get 2x. And after that, okay, now my suggestion is you let the dx be du over 2x. Okay, now let me repeat. First, we are going to take the function, right, to represent by u, and we differentiate the u. Okay, now the reason we differentiate the u is we want to replace the dx. This dx, we need to replace by du. That's why we differentiate. Okay, so after that, replace this one with the u. Okay, so you can see here, after replaced by u, we get this thing. Okay, and we have square root of u. After we replace by u, we have this. And the dx replaced by du, so we have this du over 2x. And then we can simplify. And after that, we only have u. Okay, so this method is called integration by substitution. All right, now any question here before we proceed? Okay, we're doing some revision. Okay, now after that, now if we have the definite integration, means that we have value here. Okay, my suggestion to you is you first integrate. After you integrate, so this one, if we integrate, we have, what do we have? Okay, students, what do we have after we integrate? Okay, good. And then divided by 3 over 2, right? Okay, now after we integrate, so we change it back to the x. Okay, we have 1 over 3. Change it back to the x. Then only we put the value inside. Okay. So now this is one method. So don't put the 4 and a 0 here, because when the integration is on u, this is not 4 and 0. No, they are not. Okay. So this is method 1. Now method 2, okay, now the method 2 is we actually change. Okay, sorry, just hold on. Okay, method 2, we actually change the value, all right, using the u here. So we substitute the x equals to 4, then we get the u is 25. Substitute here. Or, and we substitute 0 into the x, then we get the u is 9. So we substitute these two values. Now back to here. Okay, then only we substitute the value into the u to get the answer. Okay, now any questions? Okay, so this is what we learned last week. Okay, now I want you to try, did you try the questions here?
No, not yet.
Not yet, huh? Okay, now I want you to try these questions. Question number 2 and question number 4. Okay, I will proceed to discuss with you in a short while. All right, I want you to try first. Okay, so student, please try this 2 method. Okay, so I'm going to provide the answer here. So in case you do not know how to continue, you can actually have a look, and after that, you continue again. Itong, I think your mic is on. Okay. Okay, question 2. Have you done? Okay, so I'm going to give a very brief explanation here. So when we have this function to integrate, now, so first we let the u be 4x minus 1. So we are going to replace this with the u. Okay, now, so usually we do two things, right? We replace the u and we differentiate. Okay, so we we find the du dx. So we differentiate this one, we get 4. Now, what is the reason we differentiate? Because we want to replace the dx with du. So we rearrange this one, dx bring up. We have 4 dx, and then 4 bring down. So now the dx is du over 4. Okay, after that, all right, substitute, replace this one with u, and replace the dx with du over 4. So we get this. Okay, so this is the u, the square root, it become the power of 1 over 2. The dx replaced with du over 4. Okay, now after that, the du over 4, this 4 here, we can take out because it is a coefficient. All right, so we take out, when we take out this one, it's 1 over 4 here. And we integrate the u to the power of 1 over 2 du. Okay, this 4 take out already. So when we integrate power plus 1, like this, using the calculator, you can get this is 3 over 2. So divided by 3 over 2. All right. Now, we multiply the 3 over 2 here with the 4 here. Simplified, we get 1 over 6. Okay, 1 over 6 here. And this u, now we change back to 4x minus 1. We change back to the function of x. So this u now becomes 4x minus 1. This is 3 over 2. So we put here 3 over 2 plus c. Okay, so this is the answer we get. Now, okay, any questions here, students? Do you have any questions? No, huh? Okay, good. All right, so this is the answer. Okay, now let's continue with question 4. Where is question 4? Okay. All right, so let's do it here, question number 4. Now, how to choose the u? Okay, we choose the complicated one. Which one is complicated? Good. So this, the right-hand side, this one is a complicated one. So we are going to choose this one to be the u. Now, actually, if you observe, when we differentiate this one, okay, when you differentiate this one, we can get this, right? All right, we differentiate this one, we get 2x. Differentiate this one, we get 4. So this is actually the baby. Okay, the baby. And this is the mother. Okay, so because the baby is actually from the mother. All right, now in this case, we let the mother be the u. Okay, so we have the mother here be the u x squared plus 4x. Okay, so after that, what do we do? Very good. We differentiate. So we differentiate. We get 2x plus 4. Okay. So now in this case, the du is actually 2x plus 4 dx. Okay, now I'm going to introduce another method here. Okay, now can you see this one? 2x plus 4 dx is actually the combination of this one with this one. These two, right? Okay, so then we actually can combine these two and let it be the du. Okay, so now now you see I don't put the 2 and 1. This 2 and 1, I will put it later. So I will just put like this. So I will put this one as the x squared plus 4x to the power of 3. And I put the 2x plus 4 behind with the dx. Okay, now this 2. All right, now become the du. And this one inside here, the mother, become the u. So the whole thing will now be u to the power of 3. Now this one is the u. Okay, it's a u. And these two terms behind here, two items behind here, it becomes a du. So we have the du. Okay. All right. 2x plus 4 dx is the du. So, okay, up to here. Are you okay with it?
Yes.
Okay, very good. Now, so when we substitute the u, so you can see now the integration become easier. All right, it's not like this, so complicated, but it becomes some easier function. So we integrate, and of course, we will have u to the power of 4 over 4. Okay, power plus 1, divide. Then, okay, of course, this one we have plus c. Okay, now, after I integrate, now I'm going to put in the value. I'm going to change it back to x. I'm going to put in the value. So integrate with, okay, I need to rewrite the equation because this time we have the value. So dx now, it becomes, I write the answer. The u, I change back to x. Sorry, it should be x squared. Plus 4x, power 4, yes. Okay. Over 4. Now, students, the plus c, when we have the value, 1 and 2 here, the c is not important anymore. Okay, because if I put a plus c here, later when I subtract, it will disappear also. So we don't have to put the plus c. Now, after that, we substitute the value. Okay, let me continue here. Substitute the value. We have 2 square plus 4, 2 to the power of 4 over 4 minus 1 square plus 4, thank you, to the power of 4 divided by 4 again. Okay, so you solve this one. Okay, anyone solve and have the answer? 5027.75. Okay, thank you. So this will be the answer. All right. So, okay, to solve this type of questions, okay, we let the complicated function be the u, or differentiate. So after that, we will replace the function and the dx with du, then you integrate. Okay, so this is all about the integration by substitution.